My name's John, and this is my Recycler Robot Fun Report. The aim of this project was to build a robot that was able to travel a course that's already designed, pick up cans at a distance or whatever distance you design, identify color, count the number of cans, and then go to a mark on the course and stop. You'll see here I just use a 16 to 60 gear ratio, two motors, two wheels, and a free guiding wheel on the bottom. This is similar to a line tracker robot I've used. This would allow the back to swivel and follow the robot. The front, you don't have to worry too much. The front was where the line trackers would be that would track the line. Also have to design some kind of picking up mechanisms to pick up cans. We had arms and claws that we could build ourselves. You'll see that the arms and claws have to work together with those bins to catch those cans. I have a servo to do the swivel on the actual arm itself. The arm is attached to a motor that goes back and forth. The claw has a motor that opens and closes, and both those, the claw and the arm, have potentiometers that would detect the area or the distance that it goes, so you could set the motor to travel to that area or that distance if you wanted to. In the end, I didn't use them. I didn't really have time to implement that. I probably need more time to figure that out. The photo sensor on the front is designed, as I said, designed to detect color. The sonic sensor on the front was designed to see distance. So you set a value of when the robot would stop, and it would execute, pick up can, see what it is, that kind of stuff, and put it in the bin and continue on. The claw front added a little bit of rubber gears so it would have a little bit more grip on the can and allow for a little bit of play of where you can stop, where the can would be able to go, because it would slide a little bit. That would be a little good to have some leeway. As said here, the sonic sensor sends out a pulse and detects detects an object, and it detects the can in front of it. In the code, you set a value of where you want the robot to stop. And you see here, you have the test run. It had a little bit of trouble sometimes. Maybe in an area in there, lose a little bit of grip on the wheel. But it wasn't too difficult since I had less jerky turns on the front, since the back was guiding it. The front had more time to not catch up, but the front had time to analyze everything. I used 3 line trackers, a left and a center, and a right line tracker. The code will be in the report as well, but the code itself says if it's on the center, go straight. If it's on the right, sharp turn on the right or left. And if it has, center and right or center and left, do little turns to get to center. And I really liked that. I really liked the other project that we did, the line tracker project. That helped me do this part. Lots of issues I found, is you can see there the LCD is in the middle, and I also wanted to put the claw and arm, the thing up front. It blocked it a little bit, and the way the wires were, they're kind of short, so you had to make more wires, and it made a little of a mess. The gears and all the stuff, all the metal up front, was very heavy. It made it a little bit lopsided. The fact that they were just motors up front on the claw and arm, you didn't have there wasn't really any braking. You had back driving that would occur, so you'd have to kind of find out the distance you need and account for back driving when the motor was turned off. So you'd have to account for that. Another thing I'd have to worry about is the claw itself. You'd have to be a little bit more precise, because you didn't want to crush the can, but you did want enough force that it would close around on the can when you picked it up. And another thing is these don't have any speed settings. I didn't implement any speed settings in the program. It was just straight one way or straight the other way. If I had more time, I could have implemented maybe some speed settings, conditions for when to stop the can, counts and such. I just didn't have enough time. That is my report, and thank you for watching. This will be posted in the Word doc, and I'll be posting the code for the program, code for this. And thank you for watching. I did like this test run. It had a little bit of slippage on this point, but I did like this. It didn't have a lot of issue at all traversing this course.